All right, this lecture is going to be a really quick one on measurements, okay? Because as a scientist, we are going to collect data. We're going to do a lot of measurements. We need to be able to share those measurements with other scientists. So here are our topics for today. So first, we need to know the difference between a number and a quantity. So a number is just that. It's a number with nothing included with it. So if you were just to say a number to someone, it's sort of this random, they don't know what it is or what it pertains to. So we need to make sure that we are very specific, and instead of giving a number as an answer, we are going to give a quantity. Okay, so a quantity makes your number more specific. It puts it in context because it's going to be your number plus the unit of measurement. So if I were to say, for example, oh, I'm super excited because in my car the other day I got up to 120. Okay, that's just the number. I just told you I got up to 120. You don't know, was that 120 miles per hour, which is crazy fast and should have gotten a speeding ticket? Or was I talking about 120 kilometers per hour, in which case I was probably just on the interstate because that's the speed limit on the interstate, right? So we've got to make sure that we include our unit, okay? All semester long, if you ever write down a number as an answer, there needs to be a unit attached to it. Okay, that is part of your answer. If you do not include the unit, you will lose partial credit. Okay, gotta have that unit. All right, so what kinds of units will we be using? So if we are measuring length, we are going to be using the meter. Okay, we will be using a meter. We will not be using inches or feet because we are scientists, so we're going to be using the meter. If we are measuring the mass of an object, we are going to measure it in grams, okay, not pounds. We'll be measuring in grams. When we measure time, the base unit is going to be seconds. We can convert that into minutes if need be, but our base is seconds. If we are measuring temperature, as a physical scientist, we are going to be using something called Kelvin. We'll learn about that later on in the semester, okay? So I know you guys have probably heard of degrees Fahrenheit, right? That's what here in America we talk about as temperature. You've also heard of degrees Celsius. That's what most of the rest of the world uses as temperature. But as physical scientists, we are going to be using a new scale called the Kelvin scale. We'll learn about that in a couple of weeks. As a physical science students, we're also going to be studying current, so looking at electricity. And current, we're going to use the ampere, shortened to amp. Okay, so the great thing about using SI units, using that scientific international unit, is that they are very, very, very easy to convert between them. So going from a gram to a kilogram or a meter to a centimeter is nice and easy because it's all based on tens. It's all in the tens. Okay, so here is this great chart that shows you if your base unit is here, how do you get from here to like a millimeter or a centimeter? How do we do that? And it's nice and easy because you just move your decimal. Let's take a look. Okay, so all you need to do is find the difference between the exponents of the two prefixes. So if you're going from centimeter to a meter, just got to find the difference. And you just move the decimal that many places. But then the question is, well, which direction do I move the decimal? Do I move it to the left or to the right? So I like to draw mine more like a stair step like this because this gives me a little more direction here. Because this reminds me, since these are lower, these are smaller, and as you move up, those are larger. So a centimeter is bigger than a millimeter is smaller than a kilometer, right? So I like to use that as that visual representation. That helps me just remember bigger and smaller. And this also gives you that direction left to right. So if you're going from a centimeter up to a meter, you have to move to the left, and so that's the direction you move your decimal in. If you're going from a decameter to a centimeter, you have to move it to the right, so you move it in that direction. Okay, so let's do an example. Let's say I have 5,670 centimeters, and I want to turn that into kilometers. Okay, so we find our starting point, centimeters, and we find our ending point, kilometers. And we just see how many times do we have to move that decimal. So starting at centi, we go 1, 2, 3, 4, 5 to the left. 5 to the left. So that's what I'm going to do in my number here. This is a whole number, so that means the decimal is assumed to be at the very end. And we're going to move it 5 places to the left. 1, 2, 3, 4, 5. Now that last little hump I made there, there's no number there. So we're going to fill that in with a 0. Okay, so that means that 5,670 centimeters is the same as 0.0567 kilometers. Okay, nice and easy. Let's do a few more examples. So hopefully you took a moment to copy that stair step into your notes. And so you can use that to do these conversions here. Okay, so we have 532 meters and we want to turn it into kilometers. If we look at our stair step, we know that to go from meters to kilometers, you have to go to the left 3 places. So we're going to go 1, 2, 3. And that's where our decimal is now going to be placed. So 0.532. Had to move it back. Okay. Here's some more practice. So I want you to be using that stair step you wrote in your notes. Take a look, see what you think it is, and I will pop up the answers for you. And let's see if you got the same thing. So let's work on number 1. Let's turn 20 centimeters into meters. For that one, we need to move to the left 2 places. So it becomes 0.2 because it went from here, 1, 2. Okay, let's turn 0.032 amps into milliamps. So we're going from the base unit to milli. Think about what direction you need to go in. And then think about how many times you need to move it. We needed to move that decimal 3 places to the right. So if the decimal's here, we need to go 1, 2, and 3. So it becomes 32. Okay? All right. Now let's turn 45 micrometers into nanometers. Now be careful because this one I'm making you go beyond that basic stair step I showed you. So going back to that chart, we got to go further. Okay, so take a look. First decide, are we going left or are we going right? And then decide how many times you need to move it. Okay, in this one we needed to go to the right and we needed to move it 3 times because that prefix went from a -3 to a, or 3 to a 6. So that's 3 spaces, 3 to a 6. Okay. All right, now let's move 805 decimeters into kilometers. Deci to kilo. Which direction do you need to go in? How many steps do you need to take? Okay, this one we needed to move to the left 4 times. Okay, all right. If you got these same answers and you were able to walk through doing the steps, not just using an online converter for you, but actually doing it on your own, awesome job. You're ready to move on and get some practice on your own, some independent practice. If you did not get these same answers on your own, you don't know how to do this, you don't understand, please get into contact with me, email, text, schedule a private meet, whatever you're comfortable with, so that we can work together with this for a few minutes one-on-one. That way you can get into the right place and knowing how to do it. Okay?